Let's continue our study of encapsulation by completing the implementation of our Frogger game. Here's our problem statement. Let's continue the development of the Frogger game. We're going to create classes that use frog, truck, and grid to implement the logic of the game. And we're going to improve the frog, truck, and grid classes. I've already done a little bit of improvement. I've added JavaDoc to the classes. Now, to me, this is just a matter of professionalism. I don't like looking at code without JavaDoc, and I don't want you to get used to looking at code without JavaDoc in it. At the same time, it does take a lot of time to write JavaDoc, and it's not very interesting, so I decided to do it offline. Now, our previous work has some very serious shortcomings. The data in the frog, truck, and grid classes can be changed by other classes in the same project. For example, let's go and add a toString method to the frog class. We're going to have a little problem with that we'll talk about when we get there, and create a new class with a frog object, and then move the class to the upper left corner by mutating the data. So I've created a new project with our Frogger class in it. Let's create an example class with a main method that we can use. Now this one I'm not going to document because this is just a test to see how things are working. So let's create a frog object and let's start it at grid.rows -1 and grid.cols over 2. That's the place that our frog object usually starts. And then do a system out println frog to see where our frog is. Now let's move our frog. And print it out and make sure that our frog is where we think it is. Now the first time we do it, it's not going to work. Well, it's working, but it's not doing exactly what we wanted. What you're seeing here is the reference. And the reason you're seeing that is because our frog class didn't have a toString method in it. So let's go and put that toString method in the class. I'm going to put this just below the instance methods and above the main program that we used for testing. So we're going to display the row and column for the frog. The method is toString, so it's going to return a string, of course, as all of our toString methods have. So what we're going to return is frog row plus col plus col. Now, you could put this in a string variable if you wanted and return that variable. This is just an abbreviated syntax that I like. Now you'll notice I completed my return statement and Eclipse is still unhappy. Let's take a look at the source of its dissatisfaction. You cannot reduce the visibility of an inherited method from object, and this overrides object toString. Well, that's not very easy to understand. Here is the fix for it. Now you're not going to really understand exactly why it has to be fixed that way just yet, but for now, if you remember to make all of your toString methods public, you won't have a problem with it. So let's go back to our example class and see how things are working. Ah, that looks better. So what we can see we've done is we've changed the data for the frog outside of the frog class without getting the frog logic involved. Remember, our frog was only supposed to be able to go up, down, right, and left. He's not supposed to be able to hop to the corner in one step. So this really means that the design of our frog class has failed, and we need to figure out a better way to do this. So we added our toString method looking at that weird error message. We created a new frog object. So what we now know is that our frog object state is not being enforced. They were supposed to jump only one position at a time, and they can jump anywhere in the world they want. They don't even have to stay on the board. So really, this is a very serious problem for object-oriented programming. Our frog class has no control whatsoever. So what we need to do is to put in access modifiers. Now, access modifiers are used for both data and method. We have a private modifier, and that's used for things that should be inside the class only, and then we have a public modifier, and that means that anybody can use it. Now, what we have in our class now is nothing. The way Java handles that is with something that's called package level access. In essence, any other class that's in the same directory can use anything it wants in that class if you don't say otherwise. Well, that just isn't good enough, as we've seen. Our example class was able to make our frog do things that frogs shouldn't be able to do. So we need to go through and put correct access modifiers on absolutely everything. Now, the state of our objects is represented by data. If anyone outside of the class can alter the data, we can't enforce a legal state. So this means that our data is almost always going to be private. There is one exception to that, and that's constants. You can make constants private, and sometimes you should, and you can make them public. The way you figure it out is you have to think about whether somebody outside of the class really needs to know about this constant. So let me give you an example of something that's a constant that you've been using that you may not have known about. You know in our array list, how when we construct a new array list object, it sets an array of size 10? That 10 is a constant. It's not documented in the array list. You really don't know where it is, but believe me, that's a constant somewhere. So that is a constant that they made private. On the other hand, things like integer max value, integer min value, math.pi, these are constants that are public. Now, you know they're public because they're documented in the API. The API only documents public stuff. So it just depends on the situation. If you're not sure, the conservative approach is to make everything private. Now, I've mentioned before that computer scientists tend to be conservative, and so that's a great place to start. If later on somebody demands that that constant be public, you can make it public. But once you've made something public, you cannot make it private, because if other people are using your code and depending on it, you're going to break their code, and that's going to make them mad. So we just don't do that. Now, method and constructors are a little bit different. The state of our data should be changed only through method invocations, and construction, of course. So these things are what are controlling the state of our data, and it's the responsibility of those methods to make sure that data is only changed in ways that are legally permitted. This means that methods are usually public. Now notice usually, not always. Constructors are also usually public. Now there are some notable examples, particularly on constructors. You may have noticed that classes like arrays and collections in math have no objects. When you have no objects, you don't need a constructor. And the way you handle that in Java is to make the constructor private. So that's kind of a sneaky little trick. It comes in handy sometimes, though. So now we're going to go and modify our existing classes. We're going to add our proper access modifiers to the frog, the truck, and the grid. We're going to make all of our data private and all of our methods public. So here's our frog class. Row is data, so it's private. Col is data, so it's private. Now we've got to decide about this symbol. Do we need to know this symbol in another class? Well, we absolutely do. And the reason we need to know it is so we're able to create the object on the grid. So this is a case where a constant has to be public. We are going to build frog objects outside of the class, so that should be public. And all of these movement methods should be public. And of course, our toString method already was public. Now let's go back to our example class and see what happens. Notice what's happened here. Example is no longer allowed to access row and column. It is allowed to call the constructor. It is allowed to call toString. But this movement that created the security violation, that's no longer allowed. So basically, we've done what we've wanted. Now, I'm going to remove the example object from this class permanently so that it doesn't mess things up as we go along. So our frog class is now fixed. Let's go to our truck class and do the same thing. So here's all of our data, and all of this has to be private. Lots of private data. Our constructor should be public. And our move method should be public. So the truck class is now fixed. Now we're going to go to the grid class. Here's the private data. Now the rows and columns, we're going to have to think a little about whether those should be public or private. In order to implement this game correctly, we do need to know what those values are in other classes. And so these are public constants. By the way, these also could move to a different class. We're going to call the class controller. So that's an option that's available. Here's our constructor. Remember, we can tell it's a constructor by two things. It doesn't have a return type, and it has the same name of the class. You do have to be careful with constructors for not doing this. Notice that Eclipse was really not able to pick up what that problem was. It did raise a little yellow flag, and that's that the method has a constructor name, so at least it gives you some warning. But remember, constructors don't have a return type. So clearing the grid will be public. Displaying the grid will be public. And setting the grid will be public. So we've just made some major changes to this class. In fact, to all of these classes, in terms of being able to support them. Let's save the files and make sure that everything's okay. As you know, sometimes when Eclipse saves files, bad things happen. So now we need to design our controller data. Now all of our controller data is going to be private. So we're going to need a frog, we're going to need a bunch of trucks, and we're going to need a grid. We're also going to need a constructor that will build the frog, the bunch of trucks, and the grid. Now in UML, when we have a plus, that means it's public, and when we have a minus, it means it's private. So this is what the data for our controller class is going to look like. Notice all of our data is public. The constructor, remember the one that's in the bottom, I've made that public. And recall that we don't usually put constructors in UML. That's not consistent with the standard, but I have found it awfully useful. Well, now we need to think about what other kind of methods we're going to need in order for this to be successful. So the controller class is implementing the logic of the game. So we need to think about what are sort of the big pieces of logic that we're going to need to make this game work. So we're going to need to design the controller methods. Well, certainly we've got to be able to move the players somehow. So the trucks need to move and the frog needs to move. So those are two methods we're definitely going to need. Remember, the frog is moved by the user. The trucks are just moved automatically. We also need to figure out if the game ended, and it turns out there are quite a few ways that Frogger can end. One thing is the frog can win. He can get to the other side of the road. But if the frog jumps out of bounds, then the frog loses, and so that's something we're going to have to check for. Also, the frog could collide with the truck, that is, the frog could jump into the truck, or the truck could run over the frog, that is, the truck could go into the frog. And we've got to check for both of those cases. We also have to be able to show the user the game, because it's no fun to play if you can't see what's going on. So we're going to need to be able to clear the screen and to display the game. Now here is a design in UML that covers the design of the controller class. We have the data that we talked about last time, the frogs, the trucks, the grid. Then we have our constructor. Now move trucks looks like what you expected, I'd guess, but move frog probably doesn't. We've never seen an input stream reader before. It turns out this is part of dealing with the problems that come about from using a console for something that it really isn't designed to do, namely play games. So we're going to have to do a little bit of manipulation. This isn't such an interesting part of it, or maybe it's the most interesting part if you're a very experienced Java programmer. So we aren't going to spend too much time on it, but I will explain a little about why that decision had to be made. We've got to be able to figure out whether the frog won. Notice I returned a Boolean there because either they won or they didn't. Again, we have a Boolean return from frog out of bounds, and we have a method that can tell if the frogs and trucks have collided. It also returns a Boolean. Clear screen and display game, they both return void. So notice the pattern. The data are all private, the methods and the constructors are all public. That is a very typical pattern for many classes. So let's talk a little bit about this input stream reader and what the heck happened with that. Well, it turns out we can't use a scanner for this program, and that's too bad because the scanner's really done great work for us. When you ask a scanner object for input from the keyboard, it does something called blocking. What it does is it waits for you to respond. Now, in a way, this is a good thing because, frankly, if it just went flying past you, you'd be really mad, particularly because computers move so much faster than people do. The problem here is that when the scanner blocks, it stops the game from executing. That is, the trucks can't move. Well, if the frog is just sitting there and the trucks aren't moving, it gives you an awful lot of time to figure out your next move. In essence, it makes the game no fun to play at all. So we had to find a way to get input from the keyboard that doesn't block. Now, this is far beyond the scope of this class, of course. This is not something that would have been easy to figure out on your own. So let me explain to you what the choice is. This input stream reader is a class that doesn't block. And so that's a good one to use. In other words, it's not going to wait for input. The construction is similar to the scanner, so that's kind of nice. It has a ready method, and ready doesn't block. So it just tells you right now, is there something waiting for you or not? Well, that's exactly what we need. It also has a read method, although the read method is kind of strange. What it does is it gets a single character, but it returns an int. Well, that's really a weird design decision. There are lots of reasons for it. It's really beyond the scope of this class, but we're going to have to remember to do a cast in order to get that character back. So there are some details about the input stream reader. Of course, you can do some more investigations online if you want to see more about this very interesting class. It turns out that I/O in Java can be a gigantic pain in the neck. It's very, very comprehensive. It's extremely well designed. It's a little hard to use when you first learn it. You'll see it a lot in your next semester of Java programming. So the next thing we need to do is implement our controller. So we're going to implement the constructor. We're going to move the trucks. We're going to move the frog. So here's our controller class. Inside the constructor, your goal is to make sure that all of the instance data is properly constructed. So let's label this instance data. That was a shortcoming of our previous documentation. And construct the objects. So grid equals new grid. Frog equals new frog. Now we have to decide where to place the frog. Remember, we were going to put it at the bottom. So that's grid dot rows minus 1 and halfway across the board. So there we've constructed our frog. And now we need to construct our array of trucks. So it needs to be an array of trucks, and we need to think about how many trucks we want. Well, we want one truck in every row of the game. But remember, we have the starting and the ending platforms for the frog, so it'll be grid.rows minus 2. We've constructed the reference for the truck array. We have constructed the truck array, but what we haven't constructed is the individual trucks. And so we need to construct those. This is the 2-layer construction process that's necessary with arrays of objects. So we're going to need to use a loop. I is 0, I less than trucks.length plus I. So we'll say trucks of I equals new truck. And now we need to give its location on the grid. Well, it'll be I plus 1, because remember, our first truck is going to be in the first line. It's not going to be on the safety zone for the truck. And then we have to find a random location for it. That is, a column where it belongs. So that will be math.random times grid.cols. Random is a method, of course, so we have to put parentheses after it. And we can see Eclipse is now not happy. The problem is that, remember, random returns a double. So when we multiply by an integer, we get a double. So we're going to need to cast that. And we need to think about whether that's going to be off by 1 or not. Looks to me like I may be off by a parenthesis, so let's do some counting. I have 1, 2, 3, 4, left parentheses, and 1, 2, 3, 4, right parentheses. So that looks okay. Well, isn't that funny? What could possibly be the problem there? We've cast grid.columns times math.random. Well, I guess we can always go and look at the error message. The constructor truck int is undefined. Well, that's kind of odd. Let's go look at our truck constructor. Well, I think I see what the problem is. Remember, we have to decide if the truck is going to go to the right or to the left, and I had apparently forgotten that. So let's create a Boolean is right and give it the value of math.random less than 0.50. There we go. Now our truck constructor is happy. So we've gone through every single piece of instance data and made sure it was correct. You'll notice that I also have not handled our data correctly here. And that's that I haven't made our data private and our methods public. So we're going to have to go through the whole class and fix that. This larger than console size, that's something we're going to use a little bit later on. I'm going to take the conservative approach and make it private. We can decide later if we need it to be public. So here's our constructor. Here's move trucks. Here's frog1. You'll notice I've got some things commented out there. Don't worry about those just yet. We've got clear screen. We've got display. Frog and trucks collide. So there we go. Our controller class now has the correct protections on it, and the ones that were in our design. So let's continue to go down and follow up with this. So we have move trucks. So that's going to move trucks either to the right or to the left. Now, what you may or may not remember, because it's been a few days since we've looked at the truck class, is that all of that is actually handled inside the truck class. The truck class knows which way each truck is going and moves it in the correct direction. So the only thing we need to do here is to call the trucks.move method for each truck. So trucks of I.move. Now that's one way to do it. If that doesn't make sense to you, here's another possibility. Oops, that should be an equal sign. And that's to create a reference for that truck object and then move it. Either way is just fine. Of course, it's more fine if you put the S on trucks, so the compiler is happy with it. The first way makes sense to me, but if it doesn't quite make sense to you yet, maybe this one is better. Let's work with move frog. That's our next method. Now, this is the part that I've done with the input stream reader. Like I say, I don't really expect you to understand an input stream reader very well at this point, so I left the code here. So we look to see if it's ready yet. If it's ready, we read this one character. Now, the reason we have to put this char cast in front of it is because read returns an integer. Kind of a weird decision. Either way, we're just going to work with it. So to move the frog, we have to do a bunch of nested ifs. So if the letter equals a capital W, or the letter equals a little w. Remember, the W key was what we were using to go up. So we'll do frog dot move up. Else if the letter equals a, single quotes, not double quotes, because these are characters, not strings, Remember, that's why we can use the equals equals instead of having to use the equals method. So A was going to the left. S is down. And D is move right. I see that I put double quotes up here instead of single quotes. There we go. Now Eclipse looks happy. Now you might want to think about whether you want to have another else here, one that would catch all the other possibilities and maybe print out an error message to the user. Stuff like that tends to be kind of annoying in a game. So basically, if you use a key that isn't the right key, it's probably best for the game just to annoy it, rather than to constantly be pestering the user about little mistakes. That's just a matter of keeping the game fun to play. Now the last thing we have to do in here is to read any other input that's available. As long as we're in this method, the user could be actually typing things in. And so we want to make sure that we kind of eat up all that stuff. Specifically, we want to make sure we eat up the new line that's going to be after the letter we want to read, because if we don't do that, we're really in trouble. So that's what's going on with that while loop. So moving the frog was pretty easy. Now here's the next thing we need to do. We need to write the frog and trucks collide method. To do this, we're going to have to end up modifying the frog and truck classes. So here we go back to our code. Here is frog and trucks collide. So what we need to do is to figure out if the location of the frog is also the location of the trucks. So where is the frog? Well, we know it's at frog.row and frog.column. But when we try to put that in, we see we've got a problem. Notice the field frog.row is not visible. Well, we know it's not visible. We made it private a few minutes ago. So we've really got an issue, and that's that the frog is concealing something that we need to use. So we're going to have to add some methods to the frog class to get what we need. Now these methods are called accessor methods, and we're going to need one for the row and one for the column. By convention, they're called get, so get row and get column. So return the row location of the frog, and we will have public int get row, and we're going to return row. And then we'll return the column location of the frog, public int get col. Now sometimes this process really bugs students because they're like, well, if you're just going to give me access to the data, why did we make the data private in the first place? Well, notice I'm giving you access to the data. I'm not allowing you to change it. So letting somebody else use the data is different than letting them change it. By creating private data and creating accessors, that makes it possible to give people a copy of your data without letting them mess up your frog. So this is how we enforce encapsulation in classes. Let's go to the truck class. Now we need to think about what we actually need to access here, because we don't maybe need to access everything. We certainly need the row, we need the left column, we need the right column. We're going to need the symbol too, because the symbol is what's going to be displayed on the grid. But we really don't need is right or is left. So we're only going to have to make 4 accessors here, not 5. You always want to make the minimum number of accessors possible, and then you can add in more later if you actually need them. So I'm going to put the accessors down here. So we'll have public int get row. Now, I'm not Java docking these right at the moment. I will Java dock them before I put them up for your review, just to save us a little bit of time. So we'll have get right column. Remember, our trucks take up 2 positions. So we're going to have to return both of them. We could decide that we only wanted to return one and then figure out based on whether it's right or left where the other one should be. But I think that that's probably not such a great idea. This better encapsulates the class. So we'll need public char get symbol 2. And here we're returning symbol. Remember, the reason that that couldn't be class data like it was in the case of the frog class is because sometimes we're using a greater than sign for trucks that are going right, and then we're using a less than sign for trucks that are going left. So there we have all of our little methods. So now we've given the controller access to things, but still forced the trucks and the frogs to behave the rules. So that's a good thing. We now can see that if frog.row, get row, the method. Well, we're going to need to compare it to all 5 trucks. I think maybe we better put a loop in here to make this a little bit easier. I is 0, I less than trucks.length plus I. So if frog.getRow equals trucks of I.getRow, so that means they're in the same row. And now here's where we need to be careful. If the frog hits either one of the columns where the truck is, it's going to get squashed. So we need to make sure we check both of them. But it's going to be an or instead of an and. So frog.getCol equals trucks of I.getRightCol, or frog.getCol equals trucks of I.getLeftCol. So if it's in either one of those, that's going to be true. Now you might think to yourself, do we need this last set of parentheses or not? Well, remember and has higher precedence than or. So if we don't put the parentheses in here, we're going to have a problem. So yes, these parentheses are actually necessary. Well, if any one of those things happen, then we return true immediately. We don't have to go on any further. Whoops, looks like I forgot an index in my array. That's not going to work. If we get to the end of the loop and none of these collisions have happened, that's when we'll return false. So that's a very concise way to write that method. So notice we had to go and actually fix our frog and truck class in order to make this possible. Now we might think about our grid class too, because we're certainly going to have that problem. So let's go to the grid class and see where we might be in trouble. Well, clear grid is fine, and display the grid is fine. So that's showing the whole grid at once, and we can set the grid. Notice we're not able to get things out of the grid. Well, maybe we don't need to. Let's think about whether that's necessary or not before we jump too far ahead. Going back to our controller, we're going to do our display method. So clearing the screen will be grid.clearGrid. Whoops, sorry, that's emptying the grid. That's the next phase. Clearing the screen is in this class, and it's called clear screen. Notice that I don't have to put an object in front of it because we're in an instance method and clear screen is also an instance method. If you feel uncomfortable not having an object there, the object that should be there is called this. That's that implicit object thing that we've talked about every now and then. Now we need to put the frogs and the trucks into the grid. So that will be grid.set, oh, what was the name of that method? Set grid, row, column, and symbol. Well, the row will be frog.getRow. The column will be frog.getColumn. And the symbol will be frog.symbol. Now notice I didn't use a frog with a little f because symbol is class data, and so that was a little nicer way to do it. It would still work if you put the little f in frog. It's just not quite as perfect. And as you've probably picked up, I like code to be very, very, very perfect. Now we've got a whole bunch of trucks, so let's use a loop to work with them. So I less than 0, I less than trucks.length plus plus I, and we'll do grid dot set grid trucks of I dot get row trucks of I dot get left column. Remember, with trucks, the symbol is actually instance data, so we'll use get symbol. And then we need to do the same thing for the right column. So let's just copy it and paste it. So we've got our frog, we've got our trucks, and now we need to show the grid. So that should be in the grid class, and it looks like the method is called display. I think I'd like to call that display grid instead of just display, because I think it makes more sense. Since we're just using our controller now, so we'll do grid.display grid. Now, if we were further along, we might not want to make changes like that to that method name because it's going to tend to break things. Now, one thing you may have noticed at this point is we've been writing a tremendous amount of code without checking it. It's an incredibly bad idea. We would have been much smarter to test every method as we went along by putting a main program in the controller class and making sure that everything is still working. So we've made our display game method by clearing the grid, putting the frog and trucks in the grid, and then showing the grid to the user. So our controller class is now implemented. Well, it's sort of implemented. I actually made some changes earlier that I need to unmake. You may have noticed them as we were scrolling around. Because I wrote this at a time when we didn't have the accessor methods in, we need to make sure that we get those comments out of there. Otherwise, our game isn't going to work at all. Those things are easy to forget. Sometimes if you leave them over on the left-hand side, it makes it a little bit easier to remember that you need to do it as you move around. Okay, now we're finally to the point where we can create the class that has the game in it. Now there are two possible choices we can make here. One is to put the main method in the controller class. Now, I've done that with students before, and it tends to run into problems. People seem to get confused when there's a controller object inside the controller class. And so I tend not to do it that way. Another way to do it is in a separate driver class. And I found that students seem to have more success when they do it that way. We can use the methods in the controller class to implement the game. I'm actually going to show you this already finished just to save us some time here, because it's not very hard to do. So let's look at the driver class. You'll notice all it has is a main program. Now it has to create the input stream reader. That's so that we can interact with the user. And notice that that comes from system.in. So it works like the scanner class does. Now I construct a controller object, and then I display the game. I also print out the prompt for the user about how the interaction works to give them a chance to play it. Now here's the main loop where the game is played. Notice it's a while true, so it's basically an infinite loop. So anytime this game stops, whether the frog wins or loses, we're going to have a system exit. That's not always the nicest way to implement it because remember, often people will want to play a game more than once, but we're going to keep it simple for now. I mean, we're doing ASCII art and we're using a console for a game, so, we've clearly decided that this isn't going to be the greatest game on the face of the planet when you make those decisions. So the first thing you want to do is to let the user move the frog. So notice that's encapsulated in the move frog method, and it does need to have the input there. Then we see if the frog is won. If the frog is 1, we show the final state of the game. Now, the first time I wrote this, I actually didn't put that in, and it was so frustrating to play, because even though you saw that you'd won, you didn't see the frog hit the far line. So you always have to think about when you're writing games, what's going to make it fun? What does the user want to see? So you don't want to leave them dissatisfied, because there are lots of other games they can go and play. Then we say system exit 1. So system exit 1 just means that everything's fine. When things are in a failure mode, you do system exit of 0. The next thing you have to check to see if the frog jumped into a truck. So there we call our frog and trucks collide. If the frog jumped into a truck, the game is over. No doubt about that. Then you need to allow the trucks to move. So that lets the trucks roll over the frog. Sorry if this is getting graphic. Ugh. So we need to then check for intersections and see if the frog got run over. So that's exactly the same code. Now, if you get to this point, we know that the user hasn't won and they haven't lost. So at that point, you need to show the new state of the game to the user. Print out the instructions so that they know what they're supposed to do still. Always nice to keep that on the screen. And then we have to pause. Now, I'm going to run this once without the pause so you can see why pausing is necessary. Ooh, we've got a problem. Well, see, our failure to debug this program is killing us. So we're in the grid class, and we've got an illegal grid position set. We know something's going wrong here with set grid. Let's first off make sure that this method isn't the problem. So R should be between 0 and rows, and C should be between 0 and columns. That looks correct there. Now we can see we've really got a problem here because we don't know what is doing the illegal move. We know it's either a frog. Well, actually, you know what? We do know that it's not a frog if we think about it a little bit, because our frogs aren't doing anything yet. We didn't even get around to entering any user input. So it's got to be the trucks that are going out of bounds. So let's look at our move method in our truck class and see what's up. Well, I think I see what the problem is. Did we ever check to see if our trucks went out of bounds? Well, we really didn't. When we move right, we can't just move to the right column +1 or to the left column -1. That doesn't work. We need to wrap around so that our trucks just don't disappear. Otherwise, they just drive off the screen and the frog can hop across the road at his leisure. So we've definitely got a problem here we need to deal with. So let's think about how we can deal with it. The easiest way when we're adding one is like this. Left column +1 mod grid.cols. So what that means is when we hit grid.cols, it will wrap around back to 0. So that's a pretty elegant solution for moving right. Now, it's probably pretty tempting to use that solution on moving left, but it turns out it doesn't work. And the reason is the mod operator, when it encounters a negative number, gives a negative value. And so that's kind of a problem. So what we're going to have to do is something different. If left col equals -1, -1 because that will be when it goes out of range, then we're going to do left col equals grid.cols -1. And of course, we'll have to do the same thing for the right col. So the left, when we're going to the right, we wrap around to 0. And when we're going to the left, we wrap around to cols. Okay. Now see, we would have found that sooner if we had done a little bit of testing before now. We might not have been quite so disappointed by our game at that point. Here we go. Now, does this game look any fun to play to you? The problem is the computer is moving forward so quickly that we really can't tell how to play the game at all. In fact, it's completely unplayable at this point. What we need to do is this. we need to actually put the game to sleep for a little period of time to give the user a chance to respond. So our pause in milliseconds, that's a constant. And notice that I set it to 500. Now, a millisecond is 1,000th of a second, so I'm putting a half a second pause in here. That seemed to be about right on my computer and with my response times. If you're a gamer, you may find that a little bit laggy. So let's take that out and see if our game looks like it's a little bit more fun to play. Okay, so now we can see our trucks moving along. And we need to move our frog. Notice I waited until our trucks went past. Also, do notice that you have to hit return, and that just has to do, and there we go. I think this might be a little bit more fun if I gave us a little bit more space so you could actually see things like the directions. Oh, I know what's wrong there. I had my cursor up there when I typed my first W to move my frog. Easy mistake to make. Okay, so we're going to move our frog up. And now I'm going to let the truck run over the frog. And our game is over. Well, that's good. Now let's try to hop off the board. So I'm going to do an S instead of a W. And we can see we've got a little problem here because it didn't detect that I was off the board. It did complain that there was an illegal grid position. So we've got a little problem there that we're going to have to work with. So we need to think about which class this is going to be in. So this is a problem with figuring out that the frog has hopped off the board. Well, when the frog hops off the board, it should not survive. So frog out of bounds. So let's see what happens here. Frog.getRow is less than 0 or greater than or equal to grid.rows. Well, that all looks good. I guess the question is, did we call the method? So let's take a look. Well, here's where we moved the frog, and we didn't check to see that it was out of bounds. So if controller dot frog out of bounds, well, that's yet another way that we can lose. Now, we don't want to display the screen at this point because the frog isn't going to be visible and we are going to get an error message. So we'll do system out print line. And then system exit 1. So let's see if that works better now. Okay, so here we go again. So now I enter an S, and our game is over. And notice we didn't get the error message. Remember, the purpose of that error message was not to communicate to the user. It was to let us know that something went wrong. Now, you can play this game, and it wouldn't surprise me if you find some other bugs in it. I know the usability isn't great, but it is kind of fun. The pause was done to slow things down to keep the game from being unplayable. So we demonstrated all that stuff flying by. Absolutely worthless. So when you give the user time to read the game board, you have to put it to sleep. And that's what creates the lag in the game. So this is going to be kind of annoying to play. If you shorten the pause, what's going to happen is the trucks are going to move faster. So you have to sort of balance how fast the trucks can move to be fair to the user, and then how much lag you're willing to tolerate. It's not an easy choice. Obviously, this game would be a lot more fun if we had done a graphical user interface. So let's now talk about the big picture a little bit. Our original design for the frog, truck, and grid class was missing some critical methods. It didn't have the accessors, but what's more, it had data that was accessible to other classes, and that is just not going to work. So we needed to make our data private and create accessor methods. Now, not all data gets accessor methods. Sometimes people get lazy and just get into the habit of putting them all in there, but that isn't correct. So constants can be public, and so they don't need an accessor. Some data doesn't need to be known by the external world. So the example of that was isRight in the truck class. That had to do with how the truck moved. It isn't something that the world needs to know. So you don't just go and routinely put in every accessor. You really have to think, does somebody else need to know this or not? The other thing I want you to notice about our designs is now that we have instant methods, our method signatures are much more simple and elegant. They look a lot more like the API, where, every method has 2, 3, maybe some methods have 4 or 5 parameters, but you don't end up with these huge long lists of parameters. This is what using instance data is doing for us. The smaller number of parameters, a lot more void return types. So our method signatures are getting much more simple. Now, the reason this is happening is because classes encapsulate data and objects. And so once the data is encapsulated, you only need to use the object name. The skills we're working on now are the skills that make it possible to create large-scale programming. And so they're really important skills to develop, even though they are a little bit hard, particularly on the design side. The implementation side is actually getting easier. Pay attention to that when you think about how hard the designs are. So keep programming.